Hello and welcome. This video let us solve some problems on modulus function. So here we need to find the range of 1 minus mod x minus 2. Let us do it in two methods. First we know if you take only mod x minus 2, this is greater than or equal to 0 because mod x minus 2 starts from plus 2 and from here let me write it again, from 2 this goes like this. So at 1 it is 1, at 0 it is 2, and at 3 it is 1, at 4 it is 2, and so on. So this is my mod x minus 2. Next I need minus of mod x minus 2. So how to do this? Let me take this, extend this. So if I take minus of mod x minus 2, every positive value becomes negative. So from 2, so it goes down like this. So this will be minus 2, and at 1 it is minus 1, at 3 it is minus 1, at 4 it is minus 2 again, and so on. So next I have to add 1 to this. I write it properly. So 1 is a constant line. This is amplitude 1. So I have to add this function with this function. So what happens if I add it? So if I add these two functions, so let us take at this point, at 2, the value of this function is 0. So this we have 0 and we have 1. So 0 plus 1 will be 1. So we'll have at 2 it is 1. At 3 we have minus 1 here. At 3 we have 1 here. So minus 1 plus 1 is 0. So at 3 it is 0. Next at 4. At 4 we have minus 2 here. This is plus 1. So minus 2 plus 1 is minus 1. So it goes like this. So it will get a line like this. At the left hand side, at 1 we have minus 1. Here at 1 we have plus 1. So 1 minus 1 0. So at 1 it is 0. At 0 it is minus 2. At 0 it is 1. So minus 2 plus 1 is minus 1. So at 0 it is minus 1. So it goes on like this. So the range is actually from, this is actually 1. So the range is minus infinity to plus 1. So but this method is not advisable because it takes a lot of time. So what we do is we do it by algebraically. How we do it algebraically is, so if I made x minus 2 greater, we know that the modulus function is always greater than 0. So now I want minus of mod x minus 2. So I will multiply by minus. So minus of x minus 2 will be, if I multiply minus, see if 2 is greater than 1, if I multiply minus 2 and minus 1, so minus 2 is less than minus 1. So this becomes less than or equal to 0. You can see here the range of x minus 2 over here is from 0 to infinity, whereas range of minus x minus 2 is minus infinity to 0, you can see here. So now I'll add 1 to both the side. So 1 minus mod x minus 2 less than or equal to 0 plus 1. So 1 mod x minus 2 is less than or equal to 1. So the range is minus infinity to 1. You can see here the same thing I have done graphically here. Let us solve one more problem. What is the range of x minus 3? X minus 3 looks like this. X minus 3, I can write x minus 3 is always greater than or equal to 0. So the range is simply from 0 to infinity. So because the function looks like this, at 3 it is 0 and it goes like this. So this value is 3. So the range of a function is the value it covers in the y-axis, which is 0 to infinity. Next problem, we have to find the domain of f of x is equal to 1 by square root of x plus root x. So this function cannot be equal to 0 as well as negative, because since we have square root, this cannot have negative value. This cannot have a negative value. Since it is in the denominator, it cannot be equal to 0 also. It cannot be equal to 0. It cannot be equal to 0. Cannot be equal to negative value. So it should be always greater than 0. It can be only positive. So x plus mod x should be greater than 0. When is x plus mod x greater than 0? If you put x negative, if x is negative, or we can do like this, if x is negative, let's say x is equal to minus 1. If you put minus 1, you get minus 1 plus mod minus 1, which is minus 1 plus 1, 0. If you put x is equal to minus 2, again this is minus 2 plus mod minus 2, which is minus 2 plus 2 is 0. So for every negative value it gives 0. For every negative value it gives 0. Let us take positive x greater than 0. Let us put x is equal to 0. You cannot put x is equal to 0 plus, because 0 plus 0 will give you 0. You cannot take this value also. Let us take x is equal to 1. If x is equal to 1, x plus mod x will be 1 plus mod 1. So 1 plus 1 is 2. So this is totally okay. So the domain is from 0 to infinity. 0 is not included. So I can say this as r plus. Next problem solved. What is the domain of x mod x? X mod x, let us plot this function. If you put x is equal to 0, 0 into mod 0 is 0. So at 0 it is 0. If you put x is equal to 1, so f of 1 is equal to 1 mod 1 is 1. So it is 1. So at f of 2 is equal to 2 times mod 2, which is 2 into 2 and 4. So at 2 it is 4. So you'll get a parabolic curve if you keep on adding, if you keep on finding the values for x. What happens at the negative axis? Negative axis, if you put x is equal to minus 1, you'll get f of minus 1 is equal to minus 1 mod minus 1, which is minus 1 of plus 1, which is minus 1. So you'll get minus 1. Put f of minus 2, you'll get minus 4, you can verify. So you'll get a curve like this. So the domain is complete real number. Domain is complete real number, as well as the range. The range is also complete real number because it covers all the values in the y-axis. So next we have an interesting problem. The domain and range of 2 minus x. The domain is complete real number, because you can put any real number, you will get some value. For you pick any real number, you get a finite value. So domain is real number. Range, to find range, what we can do is, we'll start with x minus 5, mod x minus 5. We know that mod x minus 5 is always greater than or equal to 0. I want minus, so I will multiply by minus. If I do minus, this becomes less than or equal to 0. Then I'll add 2 to this, 2 mod x minus 5 less than or equal to 2. So the range is minus infinity comma 2, and 2 is included. So option C is correct, because the domain is R and the range is not option C, because it's open to here, so it should be closed. So this value option B is correct, because 2 is closed here. Thanks for watching.